Hello all, this is ML Naruto. Welcome back to my channel. So now, today I'm gonna explain, today I'm gonna teach you the first chapter of Quantitative Aptitude, that is the numbers. So why I'm teaching this Quantitative Aptitude? This is not only important for the competitive exams, but also most important factor for us, the freshers in the IT side. Okay, for all the people who are actually looking for a job as a freshers in IT side, this topic is the most important one. If you don't know, just please learn this concept via my playlist. This is the important factor here. So I'm going to teach this topic, quantitative aptitude, today. But before that, just look at this amazing quote, that is, all birds find shelter in rain. Eagles avoid rain by flying above the clouds. Problems are common. Attitude makes a difference. So, what does this mean? What does it mean? So, the meaning of this quote is nothing. It depends upon the way of looking uh, towards a problem. For example, see here, when it is raining, all the remaining birds are actually looking for a shelter to cover themselves. Why? Because it's their own attitude. They are actually following the rest of the people. But here, instead of finding a shelter during the rain, eagles are actually thinking out of the box. Like eagles are actually thinking. Uh, they are actually not following the rest of the crowd. They're actually thinking something different. That is, if we fly above the clouds, we can easily avoid the rain. So that's the perspective of the eagles. So this is what making eagles different from the rest of the crowd. So this kind of attitude we need to develop in order to make in order to make a difference. So this is the meaning of this quote. So let's deep dive into this topic, quantitative aptitude. So now I'm gonna teach you the numbers here. Okay. So first of all, uh, okay. Okay. So first of all, here I'm gonna write here. Let's see. I'll start this from here. Like, okay, this is the units place, and this is the tens place. This is the hundreds, and this is thousands, and this is 10,000s, and this is lakhs, and this is 10 lakhs, and this is crores, and this is 10 crores. So the system will be, the system is in this particular order. So now what I can do is I'll give you some random numbers, like I'll give you some, let's say 6, 3, 8, 5. Oh, sorry. Oh, where is my? So I'm gonna write here some of the numbers, like 6, 3, 8, 5, 4, 9, and 2, 3, 8, 0, 9, 1, 7, and 8, 5, 4, 1, 6. 009 and 56130790. So these are all the numbers which I have which I was given. So I want to assign all these numbers according to this particular what do you call number system. Okay. So first of all, in the units place, if I want to write down this particular, see, if I want to write down this particular number, so how can I write this? So that's pretty much simple. Like I just want to start from the left of this number. So if you just look at this particular uh, number digits, so what is the far most rightmost number? That is 9. So you can write this particular 9 here right under the units here. Okay. So that's it. And okay, and you can write this particular 4 under the tens here, and you can write this under the hundreds, and 8 under the thousands, and 3 under the 10,000s, and 6 under the lakhs. So how do you pronounce this particular entire number here? See here, units, that is ones, tens, hundreds, thousands, 10,000s, and lakh. So you can pronounce this particular entire numbers like 6,38,549. So by this, you have defined this particular, I mean, 6-digit number, right? So how do you write this particular uh, 1, 2, 3, 4, 5, 6, 7, 7-digit number? How do you write this? So that's pretty much simple, like in the same way as we have did before. So 7 in I mean 7 under the units place, and 1 here, 9 here, and 0 here, and 8 here, 3 here, 2 here. So how do you write this particular number here? So that's also pretty much simple, like 9 and 0, 0, 6, 1, 4, 5, 8. Okay, so how do you write this particular number? That is the last one here. So that's also pretty much simple. 0, 9, 0, 7, and 0, 3, 1, 6, and finally the 5, right? So how do you pronounce this? See, it's starting from the lakhs position. So right, and it's see here, and what is the place of this particular digit? 3, that is 10,000s, right? So we can pronounce it according to this particular headings. Like I can pronounce this as 6 lakh. Okay, I can pronounce this as 6 lakh, 6 lakh. So 38,000. Okay, 38,000. These two numbers together making a 10,000. So like 38,000, 6 lakh, 38,549. Right. So now, how do you read this as? See here, it's starting from the 10 lakhs, right? So we can read these two numbers together as 23 lakh. Okay, so 23, 23 lakh. Now see here, 10,000. So we can read it as 23 lakh 80,000 and 917. We can read it as like this. And when you look at here, we can read it as 8 crore 54 lakh 16,009, right? And when you look at here, we can read it as 56 crore 13 lakhs 7,090. So by this, we have already defined the number of digits of a number, right? So this pretty much simple, like we need to just place the digits of a particular number according to this particular number system, right? So whether it is rightmost number, you need to place this under right under the units place, and when it is one digit far away from the units place, then you need to place this particular number right under tens place, and and so on, like hundreds, thousands, 10,000, lakhs, 10 lakhs, crores, 10 crores. Like this, you need to keep those numbers according to that particular place. So this will be the key. This will be the key for understanding any of the numbers here. So now, uh, so this is one of a kind of situation. Now, what I can do is I'll just give some kind of numbers in a textual format. I mean, like this. See here, I want to give one number like 9 crore, 4 lakh, 6,002, and I want to give another number like 12 crore, 7 lakh, 9,000, right? 200, 9,207, and I want to give third number is 4 lakh, 4,040. Okay, now fourth one is 21 crore, 60 lakh, 5,014. So here I have written this entire numbers in a word format. See here, when you just visit any bank, here inside when you want to deposit some kind of amount inside your bank account, you'll have some kind of form like this. Okay, here you need to enter your amount in numbers. Okay, like for example 30,000. If it is 3,000, like this, I need to enter the amount in number format. And also, besides, I need to enter this same amount in the word format. Like I need to write this like 3,000, 3,000 only. See here, did you remember this? This is the amount inside in a word format. So just like this, I have given the same format which is in a word format. Now, what I want to do is I want to represent these amount in a number format. So how to do that? So just look at here. So how can we do this? See here. First of all, see here, 9 crore 40 lakh 6,002, right? So if you want to, as a beginner, if you want to represent this entire amount in the numerical format, so what you can do is, my suggestion is to, if you are a beginner, my suggestion is to just keep the headings like this, which we have did before, like which we have done before, like see here. Mm, okay. So see here, like this: ones, tens, hundreds, thousands, then thousands, lakhs, 10 lakhs. Crores. 10 crores. So if you keep these headings like this, it will be very much easy for you to represent all these amounts in a number format. See here, first of all, what is there in, at the leftmost, at the rightmost position here, that is, it has 2, right? So we need to place the 2 inside this particular one's heading. And here, 6,000, right? So here it has some 6,000. So how do you write 6,000? So you just need to write this particular number 6 and right inside, right under the this heading like 1,000. And after that, you need to put 2 zeros. Together, it makes 6,002. Okay. And now it has 4 lakh. So just go to the lakhs position here and write the 4 here and keep 1 0 here. Why? Because there is no number in between these 60,000 and 4 lakh. So we need to put this 0. Together, all these numbers will make a figure of 4 lakh 6,002. Okay. And now just go here and look at here 9 crore. So just go to the crores position here and just place the 9 crore here and keep 1 0 here in between this. So together all these will make like 9 crore 4 lakh 6,002, which is nothing but our amount in word format. This has done. Okay. Now just look at here. 12 crore, right? 12 crore 7 lakh. Okay. So how do you do that? That's pretty much simple. See here, just keep the number which is the rightmost position here, that is 7. Just keep this here, 7. Okay. And after 7, what is there here? 100. What 100? 200. So just go to the hundreds place and keep here 2 and keep a 0 here. Together it makes 207, right? Now just look at what is the another number here, 9,000. Just go to the thousands place and write here 9. Okay. And just go to the next number here, that is 7 lakh. Just go to the lakhs place and keep 7 here and keep 1 0 here. Together it makes 7 lakh 9,207. Okay. So up to now we have we have already written here, and we are only left with one number, that is 12 crore. Just go to the just go to this particular that is 10 crore. Why? Because I'm saying why? Because 10 crore. Why? Because see here, it is already exceeding the number 10 here, which comes under 10 crore part. If it is 1 crore, 2 crore, 3 crore, and up to 9 crore, then it will be under this part only. Why? Because it is singular. Okay. If it is exceeding the singular digit, that is, if it is making like 10 crore, 11 crore, and so on, then it should come under this 10 crore part. So I need to write here 1 and I need to mention 2 here and I need to keep 1 0 here. So together it makes 12 crore 7 lakh 9,207, which is our amount in the word format. So this is done. So just look at another one, 4 lakh 40,040, right? See here, what is the last rightmost digit here? 40. So just go to the tens place here and keep 1 4 and 0 here. Together it makes 40. And now just look at here, 4,000. Just go to the thousands place. Now here 4 and keep 1 0 here. So together it makes 4,040. Now look, go here 4 lakhs. Just go to the lakhs position here. Just keep 1 4 and keep 1 0. So together it makes 4 lakh 40,000. 4 lakh 4,040, which is nothing but our amount, 4 lakh 4,040. This is done. And now we are left with only one kind of question, that is, see here, what is the last number? 14. Just look at here, 14. So how to do that? So 14, how do you write this 14? 14 is nothing but it's not a singular one, it's a double digit. So when it is 14, you need to write 1 here and 4 here. Okay. Now what is that? 5,000. Just go to the thousands place and keep 1 5 here and keep 1 0 here. So together it makes 5,014. Okay. Up to now, up to here, we have written already. Now just look at this 60 lakh. Just go to the 10 lakhs here and just keep one six here and 1 0 here, and then another 0 here. So together it makes 60 lakh 5,014, which is up till here we have already written. And now we are only left with one single position, that is 21 crore. Just go to the tenth one. I mean 10 crores part. And now just go to the 10 crore part. And now see here 21 crore, right? So keep 1 2 here and 1 here, 21 crore. Sorry. So keep 2 here and 1 here. So together all these can make like 21 crore, 60 lakh 5,000. See, I'll show you. 21 crore, okay, 60 lakh and 5,014. So which is nothing but our amount in a word format. Okay, so this is done here. So like this you can represent, if you are given these kind of numbers, you can represent them in a word format like this. And if you are given with these kind of amounts in a word format, you can represent them to in number format like this. Okay, you can do whatever you want. So now I want to teach you what is meant by a now I want to teach you 1 minute. So now I want to teach you what is meant by a face value and a place value. Okay, so what is a face value and a place value? I'm going to teach this. Okay, so for, and remember this thing, we can also call this place value as local value. Okay, so whatever may be the name, both are the same. Local value we can call, or we can also call it as place value. So what is meant by face value? For example, we are given a number like see, we are given a number like 6872. Okay, and inside this 4-digit number, we have 4 digits: 1 digit, 2nd digit, 3rd digit, 4th digit, right? So what is the if I ask you a question like what is the face value of a 2? What is the face value of 2? Face value of 2 is nothing but the 2. What is the face value of 7? Nothing but 7. What is the face value of 8? Nothing but 8. What is the face value of 6? Nothing but 6. So together, see, the face value is nothing but the itself. The value itself is nothing but a face value of a particular number, of a particular digit, specifically. See, I'll give you another example. Let's say I have a number like 7, 2, 9, 8, 6. So I want to know what is the face value of this particular, each number, each digit inside a 5-digit number. So I want to know what is the face value of 6 here? Nothing but 6. What is the face value of 8 here? 8, 9, 2, 7. So did you understand what is meant by face value? Face value is nothing but the value of its own, right? Face value of a digit in a numeral, that is inside a 5-digit number or any digit number, the face value is its own value, right? If it is 6, then the face value will be that particular value, that is 6, 8, 9, 2, 7. That's it, right? Whatever may be the place, the face value of any particular digit is that particular value itself. Okay, so that's it. And now if you want to know what is meant by place value, so I'll just explain what is meant by place value with the same example here. Like, I want to give 6, 8, 7, 2, and I want to know what is the place value of this particular uh, 2. I want to know what is the place value of this particular 2. 2 is in the ones position, right? That is the units digit. So I can say the place value of this particular 2 is nothing but 2 into 1, right? And I want to know what is the place value of this particular value, that is 7. 7 is in the tens position, right? So I can say 7 into 10 will be the place value. Now I want to know what is the place value of this 8. 8 is in the hundreds position, right? So I can say 8 into 100 will be the place value of this particular digit. And I want to know what is the place value of this 6. So 6 is in the thousands position, right? So 6 into 1000 will be the place value of this particular digit, right? So the place value can be identified like this. Okay, so I'll give you another example. See here, if I have 7, 2, 9, 8, 1. So how do you find the place value of each of the digits in a in this particular number? So how do you do that? That's pretty much simple. See here, I can say, first of all, I'll go to the units digit, that is 1, right? So I can say place value of 1 is uh, 1 into 10, that is equal to 10 here. Okay. So what is the place value of 8 now? 8 into 2. 8 is in which place? See here. Oh, sorry. So actually, 1 minute. So first of all, I want to know the place value of 1. So how can I do that? 1 into 1. Why? Because 1 is in the units place itself. Units is 1. Okay. So 1. So what is the place value of this 8? Nothing but 8 into 10. Why 10? Because it's in the tens position, right? It's in the tens digit, tens place. So I can say 80. So what is the place value of 9? Nothing but 9 into 100 equal to 900. Why? Because 9 is in the hundreds place. Okay. And I want to know what is the place value of 2. 2 into 1000, nothing but 2000. Okay. Now I want to know the place value of 7, which is nothing but 7 into ones, tens, hundreds, thousand, 10,000. So I can say 7 into 10,000, which is 70,000. This will be the place value, right? Did you get this? And what if I have some kind of digits like this? For example, if I have a digit like 2, not 1, 0. So I want to find out what is the place value for this particular, okay, for this particular digit. I want to know what is the place value for this particular digit. So how can you do that? So almost the symbol. Just go here. Just go to the units place here. What is this? 0, right? So 0 into what is the place value here? That is nothing but 1, right? 1 into 0 means 0. Okay. So just go to the second place here. That is tens place. So what is the place value here? 1. 1 into what is the digit here? Tens place, right? So 1 into 10 is equal to 10. Okay. And now go here. What is the value here? 0. 0 into 0 is in which position? That is hundreds position, right? So 0 into, we can write 100, that is nothing but 0. What is the place value here? 2 into thousands position, right? So 2 into 1000 is equal to 2000. So you just need to remember whatever may be the place is, okay? Whatever may be the place is, so whatever may be the place is, uh, whatever may be the place is, the zero has the place value always as 0, right? If you are spotting out any 0 in any of the number here, in any place, whatever may be the places, it only has the place value as 0. The place value of 0 will always be 0, right? Just remember this thing. Okay. So, okay, I'm done with this digits and places here. And now I want to explain. Now I want to explain some kind of types of numbers here. So I just want to explain some of the types of numbers. So how many types of numbers are there in our numerical system, number system? That is, we have some natural numbers. Natural numbers, two whole numbers, three integers, four even numbers, five odd numbers, and six prime numbers. And then composite numbers. And eight, finally, coprimes. So now I'm gonna teach you all these eight kind of numbers, right? So first of all, okay. So first of all, let me explain what is meant by a natural number. So first of all, I need to explain what is a natural number. Natural numbers are nothing but see here. 1 minute. See here, natural numbers. So what is meant by natural number? Natural number is nothing but so natural number is nothing but 1, 2, 3, 4, and so on, etc. Okay. So these are all the natural numbers. Okay. What is meant by whole numbers? Every natural number is also a whole number and including zero. Okay. Along with the 0, 1, 2, 3, 4, and so on. All these are all the whole numbers. What is meant by integer? Integer all in every whole number is always be an integer. Why? Because see here, and so on, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on. It will goes on. There is no, there is not even a, lower limit, and there is not even a upper limit. Okay, there are no caps for lower limit and upper limit here. Why? Because see here we have a cap, that is 0 will be our lowest value in the whole numbers. 1 will be our lowest value in our natural numbers, but there is no lower limit and upper limit for integers. Why? Because it will goes on decreasing and it will goes on increasing. It will almost reaches to infinity, so there will be no limit here. And what is meant by the even numbers? Even numbers are nothing but the numbers which are perfectly divisible by 2. Let's say, what are the numbers which are divisible by perfectly divisible by 2? Nothing but 2, 4, 6, 8, 10, all the multiples of 2, right? 12, and so on. Okay, these are all perfectly divisible by 2. So that's why these are all belong to even number category. And what is meant by the odd numbers? Odd numbers are nothing but the numbers which are not perfectly divisible by 2. See, for example, if I have 1, is it perfectly divisible by 2? No. And see here, uh, and 3, 5, 7, 9, and 11, 13, 15, and so on. All these numbers are not perfectly divisible by 2 here. So that's why we are actually, so that's why these are all the numbers which are actually belong to odd number category. And what is mean by the prime numbers? Prime numbers are nothing but the numbers which are divisible by themselves and also divisible by 1. So those are all under the category of prime numbers. For example, if I say uh, if I say let's say 1 here. 1 is divisible by 1. Okay. Okay, no worries. And 3 here. 3 is divisible by 3, and also it is divisible by uh, 1 here. Okay. And 5, 7. Okay. But 9 is not a prime number. Why? Because here it is actually divisible by 9, and it is also divisible by 3, and it is also divisible by 1. So this will not be the case. The prime number should only be divisible by that particular itself. I mean, the prime number should only divisible by itself, and it also divisible by should also divisible by 1. So 11 will be the prime number. Okay, and 13 will also be the prime number. But 15 is not a prime number. Why? Because it's actually divisible by 5 and 3 and 1. So it should not be the prime number. Okay. And when you look at here, 17 will be the prime number, and 19 will also be the prime number, and 20 is not, 21 is not, 22 is not, 23. So likewise, these are all the prime numbers. So, but I'll give you a solution, like how to easily find whether a number is a prime number or not. I'll give you the solution here. But before that, just let me explain what are mean by the composite numbers and what are the co-prime numbers also. Then, then I'll just give you the easiest way to find out what is meant with. How can we find a prime number? Okay. So, but before that, just look at here. What is a composite number? Composite numbers are nothing but all the natural numbers which are not prime are called composite numbers. See, all the natural numbers which are not prime are known as the composite numbers. For example, see here, natural numbers 1, 2, 3, 4, 5, and so on, right? So inside these numbers, which are prime and which are not prime, all the numbers which are not divisible by any other number except itself and 1 are nothing but the natural numbers. Are the prime numbers, right? So other than that, all the other numbers are belong to composite numbers. For example, see here, 2 is a composite, 4 is a composite, 6, 8, and so on. These are all the composite numbers. Okay. And what is meant by co-primes? Co-primes are nothing but the numbers. Numbers are said to be co-prime. Co-prime if their HCF is 1. So what is meant by this? I'll give you an example. Don't worry. See, for example, if I want to know whether two numbers are co-prime or not, see here. First of all, I have the 20 and 25. I want to know whether these two numbers are co-prime or not. So let's have a prime factorization here. So 2 tens 20, 2 fives, 5 ones. Okay, and here I have 25. So I can't divisible. I can't divide this. So with 2, so I'll choose 5. 5 is 25, and 5 ones 5. So see here. Here, what is the see here? 2 square. 20 can be written as 2 square into 5, right? So here, what is the how can we write 25? 5 square. So what is the least here? So in the least case, we have at least 1 5, and here also inside this 5 square we at least has 1 5. So our HCF would be 5. So this will not a co-prime number. These two are not a co-prime. Why? Because I need to have the HCF as only 1. Okay. So, but here we are getting the HCF as 5. So it's not a co-prime. Then what is a co-prime number? So for that, let's have a look at here. 4 and 5 here. Just look at here. So if I want to divide this 4 like 2 twos 4, 2 ones, and 5 here, 5 ones 5. So what is the common here? So how can we write this? We can also write this 2 square into 1, right? We can also write this 5 into 1. So what is the common part here? 1. 1 is the common part here. So our HCF will become 1. So these 4 and 5 are the co-primes. See, these are the co-prime numbers. So that's why in this way, in this manner, you can find out whether two numbers are co-prime or not. See, I will give you another example for the co-prime here. For example, I have the two numbers like 8 and 11. So how do you find whether these two numbers are co-prime or not? Let's just do prime factorization. 2 fours, 2 twos, 2 ones. And for 11, 11 ones, 11. So see here, what are the common things here? Here I have 1 in common and here I have 1 in common. So our HCF would be HCF equal to 1. So then these two numbers are co-primes. See, like this we can find out uh, whether two numbers are co-prime or not. Okay. So by this we have already completed all the uh, eight types of numbers, but we are only left with how to easily find whether a number is a prime number or not. So now I'm going to explain that thing here. Okay. So for example, we have some kind of numbers. We are actually given with some kind of numbers like 137, 173, 319, 437, 811, and we want to find out whether any of these numbers are prime number or not. How to do that? Just look at here. Just pick one kind of number here. So I just pick 137 first. So what is the nearest square number? Okay, what is the nearest square number? Like we have the squares, right? 1 square equal to 1, 2 square 4, 3 square 9, 4 square, 5 square, and so on square. Like we have 11 square, that is 121. Okay, and we also have 12 square, that is equal to 144. Okay, so we need to pick one square number which is greater than this particular number. Okay, so after 137 we have the highest, we have the square number which is greater than this 137, that is 12 square. So I'm picking up that particular number, that is 12 square is greater than 137, right? Okay, so now what are all the prime numbers that are less than 12? Nothing but uh, I mean 2, 3, 5, and 7, and 11. So these are all the prime numbers which are less than 12. Okay, so and we want to check whether this number is actually divisible by these all these numbers or not. If it is not divisible by all these numbers, then we can say that this is a prime number. See here, can we divide this entire number with the 2? No. Why? Because we can't divide this with the 2. And can we divide this entire number with the 3? See here, can we divide? No. Can we divide this entire number with the 5? No. 7? No. 11? No. So what to do now? We can declare it as a, since we can't divide this particular number with 2, with 3, with 4, with 7, with 11. So hence we are actually declaring that 137 is a prime number, right? So by this way we can find out easily whether a number is a prime number or not without wasting much time. See, I just explained the same topic with this particular example, like 173, right? So here, just look at here. So 173. So what is the greatest square which is greater than the 173? What is the square number which is greater than the 173? Like we have 13 square, that is 169. I think this would be the lowest one, and we also have 14 square. So we also have 14 square. I think 256. I think let's divide here. 416, 5, 4, 1, 6, 11, 216. Okay, 216. So 14 square is nothing but the 216, right? Oh, sorry. 5 plus 4, 9. Okay. 196. Okay, 196. So 196 is still greater than 173. So we can say 14 square is greater than 173. So I want to write down all the prime numbers that are less than 14. What are all the prime numbers? 2, 3, 5, 7, 11, and 13. So these are all the numbers which are less than 14. I want to make sure whether any of these numbers are actually getting divisible by, getting divided with 173 or not. I want to make sure. See, can we divide this? Can we divide this particular number with 2? No. With 3? 7 plus 3, 10 plus 1, 11. So no. With 5? No. With 7? No. So with 11, no. With 13, no. So hence we can declare it as a 173 is a prime number. We can declare, right? So likewise we can find out whether if any particular digit or if any particular number is a prime number or not. We can do like this. So that's all for today. And tomorrow I'm gonna explain uh, the divisibilities of all the numbers, like what is the divisibility condition for 2 and divisibility condition for 3, 9, 4, 7, 8, 10, 5, 11, all these things. And I'll also give some kind of example solving problems so that we can have a better practice here. So the tomorrow's topic will be divisibilities. So tomorrow's topic will be divisibilities. Inside that, I'll explain 2, 3, 9, 4, 5, 10, 8, 11. All the divisibilities of these numbers I'll explain. Okay. Divisibility conditions by these numbers. Okay. And also besides that, I'll also give you some, I'll also solve some of the problems, example problems. Example problems here. Okay. So that's all for this session. I'll see you in the next video. Bye bye. Happy meal. Jai Hind.